I think we had finished this. Hello. Hello. Boys, can you hear me?
Yes, ma'am.
Yeah. We have finished this slide. Uh, I should repeat it again. Good morning, all of you. Good morning, all of you.
Good morning, ma'am.
Good morning.
Uh, do you wish me to revise the slide once again? Or is it
Yes,
okay? Do you wish me to revise it again?
yes, ma'am.
Okay, fine. Now, I need to ask you one question. Which type of force is applied on an aeroplane? Is it a balanced force or is it unbalanced force? Can you give me that answer? Hello. Which type of force is applied on an aeroplane? Is it balanced or unbalanced? I told you already what happens to a balanced force, right? In earlier slides, we had already explained.
Unbalanced.
Exactly. That means it is moving forward. Now, in this case, the movement is one direction. Do you agree with me? Hello. Hello.
Yes, ma'am.
Okay. Now, how many forces are applied on it? One is the weight, the gravity which is pulling the aeroplane down, the thrust, right? The air which is giving the aeroplane the push from bottom so that it can move forward, and the tail which is dragging it backwards, and the lift that it gets due to the upthrust of the air. So all these types of forces are applied on an airplane when it is moving up in the air. You understand? But all the forces are not balanced. Had it been balanced, do you think the aeroplane will move up in the air? If all these forces would have been balanced, do you think the aeroplane would have moved in the air or would have taken a height or would have gone forward? No, it would be still. It would not move, it would be at rest. You understand now? Yes, boys. Had it
Yes,
been
ma'am.
balanced forces, the plane would not have moved from rest position. Got it? Because it is an unbalanced force, so the thrust towards the front makes it go towards the forward direction. Understood, beta? It's all
Yes, ma'am.
unbalanced forces. It's all unbalanced forces that makes it move forward and take to a height. So it can speed up, it can accelerate, it can go up, it can maintain a height, it can come down, it can soar up, it can do anything, it can change its direction, it can do anything. You understand? Because we know when the velocity or the acceleration of the plane increases, the plane goes up in the air, more up in the air. You got it? And everything gets unbalanced because the velocity is increasing. So obviously that force is not balanced, and that unbalanced force is making the plane to fly up in the air. You got it? Hello, did you understand better? The one who had asked me to repeat? Did you understand better? Okay. Fine. Can anyone explain? Just looking at the picture, can any of you explain what's going on? Any of you? If it is half, whatever comes in your mind, can you explain?
Ma'am, the force is applied by the hand.
Exactly.
Uh,
Fine. That is
uh,
capital F. That is
yes.
capital F. I will help you out. That is capital F. Right. So you are
Okay.
pulling it. What you are doing, Vita?
Pulling it.
You are pulling the object. So this is the object. Right? This is the
Yes.
object. You are pulling the
Object.
object. Right. Fine. So when you pull
Then,
the object, what other forces are applied on it?
yes, ma'am. First, frictional force. Second,
Exactly.
gravitation force.
Just a moment,
And
Vita. Just a
hmm?
moment. Let's take one by one. You said
Yes,
frictional force, which is
yes, ma'am.
that small f, isn't it?
Small left. Yes, ma'am.
Small f. So frictional force, here it is, you can see over here, the capital F and small f. Can you see this? Can you see this? Capital
Yes.
Yes,
F
ma'am. Yes, ma'am.
and small f. Can you see this? The sign that is in between, we'll talk it about later. Okay. The third force, which is the third force you said just now?
Gravitation.
So it becomes the weight.
Wait. Yes, ma'am.
Absolutely right. Okay,
Mm.
weight. And due to the weight,
Mm.
there is upward thrust also. The table
Mm.
is applying an effect, a force on the object, and that is reaction, which is moving upward, right?
Mm. Yes, ma'am. Yes, ma'am.
Okay. Now,
Mm.
when the object will be pulled, can you tell me? When
Mm. When the
force,
object is pulled,
when the force is
pulled.
greater than
Acha, greater than
frictional
the F,
force.
small force. Mm-hmm.
Yes. Greater than the frictional force. Then only I can see the body moving.
Yes, yes, ma'am.
As simple as that. Had
Mm.
frictional force more than the
Mm.
force applied, the body will not move. Simple.
Yes,
What do you
ma'am.
say? All of you understood better? So what it
Yes.
is over here, this body will move here. How come the body will move here? Because the applied force by the hand, capital F, is more than the frictional force, that is small f, and the body gets displaced. The body leaves its original position and takes on to a final position. Is it clear? Is it clear to all of you?
Yes. Yes.
Please read better.
Weight of the block is balanced by the reaction by the table on the block. As long as the applied force F is less than the frictional force, the block will not move.
Okay, it's okay. See
Yes,
the
ma'am.
line, read the line. Is it okay? It's confirmed that whatever we are saying, whatever we are doing is absolutely correct.
Yes, ma'am.
Yes. Okay.
Yes.
So we will go one by one. So things become very clear to us. Okay. Which is
Okay,
the
ma'am.
third line, beta?
Third line, when the applied force is just equal to the frictional, the body may move with uniform velocity.
Exactly. So when the body starts moving, that means the frictional force and the applied force is absolutely equal. And then when it starts increasing, we can see the apparent movement of the body, right?
Yes, ma'am.
Okay. Then
Then, just a second. Okay.
the last one.
Then, okay. When the applied force is greater than the frictional, the body moves with acceleration.
As simple as that. And if what I call this acceleration as, there is a change in velocity, right? There's a change in velocity, and that means it is acceleration. It is the speed or the velocity is increasing. Got my point? Because I'm moving it towards myself. So I'm increasing the speed. What do you say?
Yes.
That makes acceleration. Change in velocity is acceleration per unit time. Any problem regarding this slide, beta?
No.
The whole nine standard? All of you boys, if you have any problem, stop me right now. I can redo it again. That's why I'm taking so much of time. Let me know better if you have any doubts.
No, ma'am. No, ma'am.
No. Okay, thank you. This is again a repetition in a manner. You will see the difference between the balanced and unbalanced force. We have already done it, beta. You know that we have already done it. This is just for revision purpose. I have taken this slide. Okay, let's start. And if you can explain to me, well and good. You're welcome. Start.
Yes, ma'am. This picture shows that the F1 and
First
F2
read.
have the similar.
Beta, first read and then explain.
Okay,
John.
ma'am. Yeah, okay, ma'am. No problem. Balanced and unbalanced forces. Balanced force. If two forces act on a body in the opposite direction, and if both the forces are equal, then the result force acting on the
The
body is
resultant
zero.
force.
Uh,
Repeat it again.
Resultant force acting on the body is zero. Such forces are called balance force. Balance force cannot change the state of rest or motion of the body.
So what do you see over here?
We
Explain.
see that F1 and F2 applying forces, both the forces are equal, so the object is not moving at all.
This, beta, it is not only equal, but it is opposite. You have to be very, very careful regarding this.
Okay, ma'am, they are opposite forces.
Equal as well as opposite, and then the resultant force becomes zero. If it will not be opposite, then it will add up beta. If the forces are equal, for example, you getting my point? If the forces are equal, yes? Hello?
Yes, ma'am, yes, ma'am.
Yeah. But if it's not opposite, it may add up. But here it is
Mm,
opposite because it is pulled apart. It is pulled from both the
yes.
sides, right? So the resultant
Mm,
force becomes zero. These are called as balanced forces. What are they called as? Balanced forces. So what happens to balanced forces? The body will not move.
mm,
The body will remain at rest.
mm.
Right? As simple as that. All of you understood, beta? Ninth standard, all of you understood?
Yes.
Ma'am.
Yes, ma'am, yes, ma'am.
Yes,
Yes, ma'am.
beta? Yes, yes. Who said ma'am?
मतलब
Want to
yes,
ask me
ma'am.
anything? Okay.
Oh,
Now we will talk about unbalanced forces. Say beta. Yes, please start reading. And anyone else? If John is not able to, can anyone else start?
Yes, ma'am.
Yeah, start please.
Unbalanced force. If two forces act on a body in opposite direction, if one force is greater than the other, then the result force is not equal to zero. Such forces are called unbalanced force. Unbalanced
Forces.
forces changes the state of rest or the motion of the body.
Simple. Now you understood? One of the force, F1, is more than F2. If F1 is more than F2, to where will the body move? Here. Right? Where will the body move? Towards F1, isn't it? And
Yes, ma'am.
if and if F2 is more than F1, where will the body move? This side. Do you agree with me?
Yes, ma'am.
All of you understand now? So the resultant force is not zero in this case, in unbalanced forces. And wherever the force will be more, the body will move towards that direction. Is it correct?
Yes.
Okay. You want me to ask any question regarding this slide? For each and every slide, I will give you 1 minute. Do you need me to explain it once again, or have you understood?
It's understood.
Okay, but the third force, see, it's all revision. Remember, we have already done it. Purposely, I've taken these slides for the revision purpose. Now, the third force is force of friction. So, first force was balanced. Second was unbalanced force. Third is force of friction. Now, you understood what are we doing?
Yes.
Yes. Okay. Now, let's start force of friction. Continue
Force
with
of
it.
friction. Force of friction is the force which opposes the motion of an object over a surface. Example: a ball rolling on ground gradually slows down and comes to a stop due to force of friction. If we stop pedaling a bicycle, it gradually slows down and comes to a stop due to the force of friction.
This is okay with all of you? Did you understand whatever the examples we did just now, or whatever examples you read
Yes.
it just now?
Yes,
You
ma'am.
agree to everything? You agree to it?
Yes,
Okay, let's see now. This we have already done, remember. Remember, we have already done this object, this one, we have done this one also due to friction, and we have done this one also. What I did, I clubbed all of them together. Do you remember doing all these examples earlier? Yes? Can you hear
yes,
me?
ma'am.
Okay. Yes, please read. Please read.
An object with uniform motion will continue to move with uniform motion if the forces acting on it, pushing force and frictional force, are balanced. If an unbalanced force acts on the moving body, then its speed or direction of motion changes. If the unbalanced force is removed, then it will continue to move with the speed if had
Acquired.
accelerated
Acquired.
acquired till
Acquired.
then.
So this is all again the same thing what we had done earlier. If an object, if any body which is having uniform motion, it is moving in a uniform velocity or speed, it will keep on continuing. If the forces which is acting on it, what are the forces which are? Now this is the body, this is the pushing force, and this is the frictional force. This is the pushing force, and this is the frictional force. They are balanced. So it will keep on moving with the same speed. You agree?
Yes,
Yes.
Yes? Okay. Now we come to the second. Now there is unbalanced force. There is a body which is already moving. This is a body which is already moving. And then what I do? I kick it. What I do? Remember football game? The ball is moving. Then I kick it. What happens? What happens? The ball may go here. It changes the direction. And the speed also changes. So direction and the speed changes of the moving ball. Agree?
Yes.
Yes? Okay. Even the cricket, the game of cricket, you hit the ball with the bat, what happens? The speed of the ball changes as well as the direction changes. Yes?
yes, ma'am.
Yes? Okay. Now we come to the third. Now the ball is moving and this is the unbalanced force, we are not applying any force. So we cross it. So the ball is moving. The ball is moving. So it will continue to move with the same speed that it had got. Got my point? It will keep on moving with the same speed. And then later it may come to a stop due to frictional force. That's it. You understood now? If I remove this unbalanced force, this is removed, the speed of the body or the object will remain the same. Any problem? Hello.
No, ma'am.
Okay. Now we are going to do certain experiments. This is Galileo's experiment, who had done certain experiments regarding the motion of an object on an inclined plane. What is called inclined plane, beta? Which has got slope. So these are called as inclined plane. That slide, what I talk about slides, which have got some degree of the plane that is called as inclined plane. So this is called as inclined. But the slope is called inclined plane. What you see over here, that a ball is moving down and later with a force it goes up. Got it? Yes? You must have observed the skaters. Have you seen the skaters? I'm not talking about the roller skates, I'm talking about the board skates. They have got this sort of uh, same type of inclined plane on both the sides. So from here they go down and then they come up and then they reach here. Again they go down and they come up. They do lots of somersault and they do stunts. Yes, have you ever observed in maybe this Discovery Channel or in Sports Channel?
Yes.
Yes, it's the same thing that we are going to work on. Okay, so let's read and then we'll do one by one. Please read.
When a marble rolls down an inclined plane, its velocity increases, and when it goes up on the second inclined plane, its velocity decreasing.
Okay, stop,
If
beta. Stop. Now, here. We'll do it one by one so that you can understand better way. Now, this is a marble, right, beta? This is a marble. It is coming down. Why is it coming down, beta? Whenever I ask you a question, I need an answer, okay? So, why is it coming down? Please be fast. Why the marble is coming down? Can you hear me? Boys, can you hear me? Hello?
yes,
Yes, can you hear me? I said, why the marble is coming down? Because of weight. That means gravity. If I say weight, that means gravity. Okay, the gravity is a force. So it is coming down. So it increases the speed. When the speed is such that it goes up in the other inclined plane. And when it is going up, it is working against the gravity. So automatically the speed, the velocity of the marble will automatically decrease. Can you give me a confirmation that whatever I said is okay? Till here it will go with the speed and then the speed will decrease. Can you hear me?
Yes.
Yes? So did you understand what I said just now?
Yes.
Now the second line.
If the inclination of the second plane,
No, no, of both the planes.
both a plane, is made a horizontal,
No, beta. You have to go up. The second line I'm talking about. You're reading the third line.
if the inclinations of the both the plane are equal, then the marble will reach the same height which it
Roll
rolled down.
down. Okay.
Rolled
Now
down.
see over here. What they are saying, if the marble has started from here, so it will reach the same height here. You understood now? They will reach the same height. That's what they are saying. That's what Galileo is saying. That the height is will be the same of the marble. It rolls down, it rolls up. Now the third line.
If the
Inclination.
inclination of the second plane is decreased, it will travel more distance to reach the original height.
Yes.
If the inclination of the second plane is made of horizontal, the marble will travel forever trying to reach the same height.
Height. Okay. Then
An unbalanced force is required to change the motion of the marble, but no force is needed to
sustain.
sustain the uniform motion of the marble.
Right. Look over here. Same thing we are going to do over here. See, this is the inclination. Okay, so the marble is going up here. Now what I did, I increased the degree to reach the same height. What it is doing, can you see this? It is taking more distance. Can you see this? This distance is more than this. Agree or not?
Yes,
To reach the same height. So it is taking more distance than the earlier one. Okay. Now let's talk. We increase more degree like this. Look over here. It's taking more distance. Yes or no? Yes? Agree? Hello? Do you agree or not? As we are changing the degrees, the distance traveled by the marble gets more. And if I make it horizontal, that means flat. See, so it is taking more distance. It will keep on and on. The marble will keep moving to cover more distance. Understood? So what is working over here? The inclination of the second plane. As you change the degree, the distance covered will be more. Have you understood?
yes.
All of you? All of you, beta?
Yes.
Now we are going to work on Newton's laws of motion. Please read.
Newton's laws of motion. The block remains at rest unless and until it acted upon by an
It is
external
acted. It is not
acted,
acting, it is acted.
acted upon by an external force.
Okay. So we know that this object will remain such until unless I push or I pull. What do you say? And that push and pull is the external force. What is push and pull, beta? It is the external force. So until unless I touch it, or I push it, or I pull it, the object will not move. This is the Newton's law of motion, that the body will remain at rest, the body will not change its position until and unless any external force in the form of pull and push is given to the object. Is it okay?
Yes.
Yes, read with it.
The ball continues to be in uniform motion
In front, what is written? Unless,
unless and until it is acted upon by an external force.
okay. Now the ball is moving. So the ball is rolling, right? It keeps on rolling. What I do, I stop it. Now this stop force is an external force. You agree?
Yes,
Fine. So I stop it. Why? Because I applied an external force. I applied, I kept my hand on the path of the ball which was rolling, and it comes to a halt, it comes to a stop. So that was the external force. So what Newton's first law of motion suggests? Continue.
a body at rest will remain at rest and the body in a uniform motion will continue to be in the uniform motion unless and until it's
Compelled.
complained by an external
Compelled. Read it
com,
again.
complained
Compelled. Beta, it is
compelled
compelled.
compelled
Very good.
by an external force to change its state of rest or of a uniform motion.
Right? So, in short, I can make it into two parts. The body is at rest, will remain at rest. The body which is moving will remain in motion until and unless an external force is applied to it. Is it clear? All of you. Boys, I'm not getting any response from
Yes, ma'am,
others.
understood.
Others, I'm not getting. The one who is reading, only that response I'm getting. It should not be so. So, if at all I'm addressing the whole
Yes,
class, I wish that you will respond like that. Okay? So, do you
yes.
wish me to continue or do you wish me to redo it?
No, ma'am, you should continue.
Thank you. So, I take it for granted that all of you have understood? Yes? So, now we come to Newton's first law of motion again. Let's start.
Newton
Yes, start please.
laws of motion. Network is the first law of the motion state that an object remains in a state of rest or in uniform motion in a straight line unless
Compelled.
compelled to change the state by an applied force.
So we already know, so I will not redo it again. We already know about it, right? The first law of motion. Now we come to a very important word, that is inertia. Okay, see what is inertia.
The naturally tending
Natural. But it is natural.
the natural
Tendency,
tendency of object to remain in a state of rest or in uniform motion is called
inertia,
inertia.
inertia, inertia. Say
Inertia.
inertia. Very good.
This is the way the first
This
law.
is why. Beta, this is why. Please read
This is
properly.
why the first law of the motion is also known as the law of inertia.
Inertia. So what you learned from this slide, that the first law of motion is also called as law of inertia. So you should not be baffled. You should not be confused at all. If I ask you what is law of inertia, what should come to your mind? The first law of Newton's motion, right? Hello.
Yes,
So first law of Newton is equal to law of inertia. This thing should be very, very uh, importantly kept in your mind. So don't be confused. So what inertia suggests? Inertia is if a body is at rest, it will have the tendency to be at rest. If the body is moving, it will have the tendency to keep on moving. This property is called as law of inertia. What you can see over here, we have done this sort of work many times, this sort of activity many times. Have we?
yes,
Can anyone explain? I'm not saying anything, but can you explain what is happening? What is shown? There's a glass, right? And there's a cardboard
Uh,
on the mouth of
it's
the
a
glass, and there's a coin. Yeah, what are you doing?
it's a trick, ma'am.
Yeah, it's a trick,
Something
exactly.
something is that what is that? A coin or something is that
It's
put
coin.
on a paper,
It is a
yeah,
coin.
coin
Yeah, it's a coin.
on a cardboard paper
Yeah,
upon the glass. So
yeah.
when we hit I mean forcefully on that cardboard,
We
the
flip
coin
the
falls,
cardboard. Which word you will say? We will flick the cardboard. You know,
flick the card.
you're a sportsman,
Yes, ma'am. Okay.
isn't
Yeah,
it?
yeah, yeah,
Softly.
yeah.
So that same thing, what you do is strike or you flick the cardboard. What happens?
So the when we flick the cardboard, the coin fall in the glass, falls in the glass.
Why? Why? What happened? The cardboard moved, but the coin was at rest. Hope you understood.
Yes, yes, ma'am. The cardboard
Cardboard
was
moved. Yes,
in a fast force. We
yeah,
called it fast
exactly.
motion.
The fast motion. But the coin was at rest. So in
Yes,
this
ma'am. So
fraction of a second, the cardboard left the place, but the coin which was in rest, it fell inside the glass, showing that the state. I did not hit the coin. I hit the cardboard. Remember that. So cardboard went into motion, but the coin, which was at rest earlier, remained at rest later also. Hope you understood. So it fell inside the glass. Got it?
yes.
Hello. We'll do all these activities later. Okay. At home also you can do and let me know. Now we going to do some detailing regarding inertia. Please start. Please start reading.
okay, ma'am. Inertia is the inherent inherent property of a body due to which uh, it resists a change in its state of rest or of uniform motion.
It's
Inertia,
saying no. It's saying no. Do
yes,
not
ma'am.
move me. And if I'm moving, don't stop me. That is called inertia. You got it?
Yes, ma'am.
Yeah. Start. Then
Inertia can be understood in parts, viz. Inertia of rest and inertia of motion.
agree.
Yeah, ma'am, totally.
Then
Mass is a measure of inertia of a body.
right. This is what you have learned today. That mass is a measure of the inertia. Next,
Heavier objects have more inertia than lighter objects.
we also know the same. Why? Because mass is more, inertia is more. Example.
For example, number one, a stone of a size of a football has more inertia than football.
Got it? Same size of football, stone and football of same size. But which will have more mass? I mean, which will have more inertia? Because stone has got more mass, so stone will have more inertia as compared to football. Second.
Example number two. A cricket ball has more inertia than a rubber ball of the same size.
So I hope you have understood this. Now, what is
Yes.
this inertia of rest? Can you see this?
Yeah, ma'am, it's a carom board.
Yes. What will happen? Can you tell me? When we strike, the bottom coins get scattered and the whole coin will stay as such, like this. They don't fall. The coins
Yes,
will
ma'am.
remain, only the bottom coin will be displaced
Remain.
from its position. Have you observed any time?
Yeah, ma'am.
Yes.
The stack of coins remain the
Ma'am, time.
same. Yeah, yes, yes, ma'am. Just 1 second.
Okay.
Okay, boys. The
Yeah, ma'am.
bottom coin will be removed, will be displaced, but the heap of the coins remain as such. They don't fall if you strike it very fast. Have you ever observed this condition?
Yes.
Yes. So that it shows that the bottom which was struck went into motion, but other heap of coins remained at rest. You understood?
Yes, ma'am.
Yes.
Fine. So I think now we come to a close and we meet tomorrow, right? Do we have lecture tomorrow? Yes, we have. So we meet tomorrow. I hope you have understood. Keep on revising every day with us. And tomorrow or today, I will be giving you the in-text questions. And I hope that you have already finished and written the rest of the textual questions and the in-text questions in your notebook. Have you?